Well, good afternoon, everyone. My name is Christine Kennedy, and I work in the Office of Alumni Advancement. And I'm very excited that you're all joining me here today for a very special talk. We have something very unusual happening this afternoon that we will be able to see. Now, I don't know where you are, but I'm in my home because McMaster is closed. And I live in Ancaster, and it's very, very, very cloudy in Ancaster. So I do not think I will be able to see what Jacqueline is going to be talking about tonight. But I am going to log in to the Lowell Observatory, and I'm going to watch it with my family down in Arizona, because hopefully the weather there is nicer than it is up here. A few housekeeping issues before we begin. So today we're going to have a little talk, and in the talk we are going to have some polls to get everyone excited and interested in learning. So you will be able to see when we launch the poll, you'll be able to answer it. It will be multiple choice, so you'll have a few seconds to answer that. And this is just fun, so please don't feel stressed out about answering the poll. And at the end, we will have some Q&A. Now, we did ask you to ask questions of Jacqueline before, and what Jacqueline did was she took a number of those questions and sort of integrated those into her presentation. So we're hoping that most of the questions you asked were answered, but if you have more questions, or for those of you who were unable to ask questions, you have the opportunity at the end of the lecture. And you will see at the bottom of your screen, you see a little Q&A icon. What you need to do is just click on that icon and type in your question. And Jacqueline and I will see those, and we'll try to get to those as many as possible. So I would like to introduce our speaker this afternoon. Jacqueline Wightman is a graduate. She just recently graduated from the Department of Physics and Astronomy, and she's also a high school teacher. So she is the perfect person to talk to you today about astronomy. She studies star formation patterns in nearby galaxies. So she is well acquainted with, everything up there. So she also did her Bachelor of Science at the University of Waterloo. So if there are any Waterloo grads out there, you can call Jacqueline a friend and a fellow alumni. And then yes, after doing in between her bachelor's and her master's, she went to Teachers College, as I mentioned, and she's a teacher. So she also has a master's of teaching from OISE. So without further ado, I'm going to invite Jacqueline to come and join me on screen.
Hello, everyone. Just give me a moment while I share my screen. So hi, and welcome to a special presentation about the winter solstice and the Jupiter-Saturn conjunction that are both happening today. So thanks, Christine, for the great introduction. As you now know, my name is Jacqueline, and I recently graduated from McMaster University with a master's degree in astrophysics. And I'm really happy to be here today with all of you, and I'm very excited to go out later today and watch the conjunction, although I am also in Hamilton, and it does look very cloudy out there today. So you should still be able to see stuff happening tomorrow and in the next week to come. So I'm going to make sure to have a look then. So just first off, I just want to hear from you. What gets you excited about astronomy? So if you can answer the question on your screens now.
Okay, we see some questions coming in. All right, everyone, 3, 2, 1. Okay, we're going to stop the poll and let's show it.
Awesome. How big the universe is one of the main answers. That's what gets me excited about astronomy too. I really love cosmology, so that's cool. We all have something in common. But today we are going to focus not on the whole universe, but on specific planets. So you might have heard in the news, which is why you're here, that Jupiter and Saturn are going to be very close together on the sky. But what does this mean? Are they close together in space, or do they just look close together? And why are they so close together? So the official word for what is happening today is conjunction, and I'm going to explain exactly what this astronomy word means. So to answer this question, you first need to know about how astronomers talk about the positions of objects in space. So just to relate that to the Earth, we use lines of latitude and longitude to identify specific points on Earth. So latitude tells you how far away you are from the equator, and that's measured in degrees. And longitude tells you how far away you are from what's called the prime meridian, which is the 0 line right there. So using this system, we can identify specific points on Earth. Even places in the middle of nowhere, not in a town or a city, can be found using this system. Every single point on the whole Earth has a specific latitude and longitude. For example, here is a map of a chunk of North America with lines of latitude and longitude. And I'm in Hamilton, so my specific point is 43.26 degrees latitude and negative 79.84 degrees longitude. So this is similar to how we look at geography in space. So there might be a lot going on in this slide, but that's okay. Just to give you an idea, astronomers use a system like latitude and longitude to identify specific positions in space. So the most common system is called right ascension and declination. So just like there is an equator on Earth, we project this equator out into space, into the sky, and this is called the celestial equator. And declination is like the lines of latitude and gives you the distance from the celestial equator, and right ascension is like the lines of longitude. So these lines here are your right ascension lines. So looking at a map of the sky now, here is a map of the north part of the sky, and they show lines of right ascension, which are emanating out of the pole right there, and declination, which are these big circles here. So the right ascension lines are measured in hours because you can think of the sky like a big clock. So the Earth spins around one day or every 24 hours. So when you're looking up, you are looking at a different spot on the sky clock. So the sky looks like it's moving, but really it's you looking at a different spot on the sky as the Earth spins around once every day. So then, now that we know some of these words, what is a conjunction? Well, a conjunction is an event when two or more astronomical bodies share the same right ascension. So that means they will be lined up on one of these lines, or any line that you can draw from the north celestial pole to the south celestial pole. So basically, they're lined up together on the sky. They don't necessarily have to be touching. They just have to be in a line. So this can happen with other planets. But what we're looking at today is Jupiter and Saturn. And Jupiter and Saturn are the two biggest planets, so that's why we call it a great conjunction when they meet at the same right ascension on the sky. So now I have some questions for you to see what you know about Jupiter and Saturn. So if you can answer these questions on your screen.
Okay, everyone have a chance. Give you a few more seconds to submit, and then don't forget to hit the submit button. Okay, let's close the poll and let's see what people have to say. So how did we do, Jacqueline?
We did pretty good, yeah. It looks like a lot of you know a lot about astronomy already. That is awesome, or at least about Jupiter and Saturn. So now I'm going to show you the answers, the right answers. So which planet is bigger? Most of you selected Jupiter, and that is correct. Jupiter is the biggest planet in the whole solar system. And which planet is further from Earth? Saturn is further from Earth, so Jupiter is closer to us. That means when it passes by Saturn in the sky during the conjunction, it's going to be in front of Saturn. And which planet is closer to the sun? Jupiter. we're also closer to the sun? It's kind of a trick question. So here is a drawing I made of the solar system up to Jupiter and Saturn. So Mercury is the closest to the sun, then Venus, then Earth, then Mars, then Jupiter, then Saturn, then Uranus and Neptune, which are off the page. Now, all of the planets in the solar system are moving around the sun along paths kind of like this, and they're all going in this direction. So the ones that are closer to the sun are actually moving a lot faster than the ones that are further away from the sun. And that's because the gravity is stronger closer to the sun. So that means that Earth is moving faster than Jupiter, which is moving faster than Saturn. So Saturn's the slowpoke out of the three. So now I'm going to ask you, how long do you think it takes Jupiter to orbit the sun? Less than 1 year, 1 year, or more than 1 year?
Okay, I think that one was an easy one, Jacqueline.
They all got it? That's great.
Okay, everyone, let's close the poll. Let's see what everyone says.
Yep, most people got it right. That's exactly right. It takes definitely more than 1 year for Jupiter to orbit the sun. So it takes actually 12 years for Jupiter to orbit the sun. That means that a year on Jupiter is actually 12 Earth years long. And Saturn is slower than Jupiter, so it takes longer. It takes 29.4 years. So you can think of all the planets like they're in a big race around the sun. Great conjunctions, which remember are conjunctions of the two biggest planets in the solar system, they can only happen when Jupiter laps Saturn in this race around the sun. And they have to do it in a spot where we can see it happening. So if we're here and Jupiter and Saturn are here, then we could look out into the night and watch them lap each other. But say Jupiter and Saturn are all the way on the other side of the sun here, then we wouldn't be able to see the conjunction because the sun would be blocking our view and it'd be too bright. So now I'm going to show you an example of a conjunction of Jupiter and Saturn based on my little diagram here and show you what we would see on Earth. So say we looked out at the sky at nighttime, so looking up away from the sun and look towards the planets Jupiter and Saturn right now. So this arrow is showing you the direction that we're looking in from Earth. So how do Jupiter and Saturn look on the sky? They look something like this. So Saturn is a bit ahead of Jupiter in its orbit, so it would be here. There's Saturn, and Jupiter's a bit behind. Remember, they're both moving to the left. You can kind of picture that based on the other diagram. So everyone's moving in that direction. Saturn's moving to the left, Jupiter's moving to the left, and Earth is actually also moving around the sun in the same direction, but it's moving faster than both of them. So now as Jupiter begins to overtake Saturn in its orbit, what happens? So this is before the conjunction. Now Jupiter is speeding ahead of Saturn. It's going faster to the left. But remember, the Earth is also moving. So interestingly, the pair of them actually look like they're both moving to the right. But Jupiter is moving faster to the left, so it's going to overlap with Saturn. And now this is the moment of conjunction when Jupiter will pass in front of Saturn in its orbit. And now Jupiter has passed Saturn. So because of the relative lengths of Earth, of the orbits of Earth, Jupiter, and Saturn, this lapping or great conjunction that we see will happen every 20 years. So now that I've explained what is happening in the conjunction, let me show you where the great conjunction can be seen in the sky today, assuming you don't have a lot of clouds. So this is my planetarium software, which is a simulation of the night sky. So this is how the sky looked in Hamilton on December 7th. So about 2 weeks ago at around 6 p.m. So Jupiter was catching up with Saturn in its orbit. There's Jupiter, there's Saturn. They're both moving that way. It's catching up with Saturn. And they're about to pass each other. So when they do, they'll be along the same line here, right ascension line, like I told you about earlier. And as you can see, they're in the southwest sky. So here is telling you the compass directions at the bottom. So this is southwest. And so that means that you'll find them if you look in the general direction of the sunset. And I actually did see them looking like this a couple of weeks ago. The planetarium makes them look a little bit bigger than they actually look in real life though. And since I paint and like to draw, I made a picture of it. So this is a painting to represent what I saw at the time. Of course, I was in Hamilton, so there were no mountains, but it was around sunset and the two giants were hanging out together near the moon. There's Jupiter and there's Saturn, and that's kind of what you would have seen 2 weeks ago. So when can I see it tonight? Well, Jupiter and Saturn will be above the horizon. So actually, they're out right now. If you had a telescope, you could go check them out. They came up around 10 a.m., but it's difficult to see them during the day because the sun is out. So they rose in the southeast part of the sky around 10 a.m. And if you have a telescope, you could see them, but we have to wait until after the sun goes down to see them with our eyes to get a good view. And that happens at 4:47. So this is sunset today using this planetarium simulation. So the best time to see the Jupiter-Saturn conjunction will be just after 5 p.m. in the southwest part of the sky, and they're going to set here in Hamilton around 6:40. So you have about an hour window to see the conjunction today between 5:30 p.m. and 6:30 p.m. And you should look to the southwest, and they'll be about 10 to 20 degrees above the horizon. So now that you know that a conjunction happens when two celestial objects have the same right ascension, so are lined up on the sky, and you also know that a great conjunction is the word for a conjunction between Jupiter and Saturn, the two largest planets, I'm going to give you a quick one-question quiz to see if you remember one more thing. So how often do great conjunctions happen between Jupiter and Saturn?
I like how you're testing everyone to make sure they're not dozing off.
Listening.
Running to their window to look for the great conjunction. Okay, let's close the polls and let's pop up.
Great. Okay. A lot of you selected every 20 years, which is what I said. Some of you selected every 400 years, and you might have heard this number in the news, and I'm going to explain why people are talking about the last one being 400 years ago. But yes, they do happen every 20 years. There is a conjunction, a great conjunction, sorry. So that's the right answer, every 20 years. So then why is this one special? So remember, a conjunction is just if they align in right ascension on the sky. They don't have to pass right in front of each other to be a conjunction. But in this case, Jupiter is passing very close in front of Saturn. So it's a special kind of conjunction. And the last time they passed this close was in 1623. So that would have been the 400 years that you were thinking about. And actually in 1623, this was just when Galileo Galilei, a famous astronomer, started laying down the foundations of the scientific method. And the next time they'll be this close is in 2080. The last time you could observe them this close was actually in 1226, because in 1623, it was daytime again. And actually, because this one's special in that Jupiter is coming very, very close to Saturn, we won't be able to see Jupiter cover Saturn again for thousands of years. So this one's very special. Another reason why this one is special today is just, it's a coincidence that it's happening on the winter solstice. So this is a complete cosmic coincidence. So now I'm going to talk to you a bit about the winter solstice, but first let's see if you know what the winter solstice is.
Okay, let's launch this.
Is it the shortest day of the year in Canada, the longest day of the year in Canada, or the coldest day of the year in Canada?
All right, just a few more seconds. I think everyone's looks like they're finished. Okay, let's close the poll and I'll publish that.
The shortest day of the year in Canada. That's correct. Yes, if you're in Canada, you are keeping track of the shortest day because you cannot wait for the days to start getting longer again if you're like me. And that is today. Today is the shortest day. And yeah, this is one of my favorite days of the year. After today, those days will start getting longer. So I'm just going to go over a little bit of what's happening with Earth's orbit that results in the winter solstice. Well, here's another little picture. So the winter solstice happens at a specific point of Earth's orbit around the sun. So if you were to draw a line from the South Pole to the North Pole, this is the axis that the Earth spins on once per day. And the Earth also orbits in a flat path like this once per year. So as you can see, the axis that the Earth spins on is tilted compared to this path. It isn't straight up and down, and that tilt doesn't change over the course of a year. So the Earth is going to move around the sun. So right now, in this position, Canada or the northern hemisphere is pointed towards the sun, so it will be warm out. It will be summertime. When we're pointed towards the sun, we get more intense sun rays and it's hotter. Now it's moving around and now it's not really pointed towards or away. So this would be fall now. And as it moves around the sun, the seasons keep changing in the northern hemisphere. And now it's pointed away. So when it is at this spot, the North Pole is the most tilted away from the sun, and that is the winter solstice. So this is happening today. So as I said earlier, the fact that the Great Conjunction is happening the same day as the winter solstice is a complete coincidence. But because this Great Conjunction is happening on the winter solstice, that means that the sun is setting nice and early, which means we luckily have a chance to see this awesome event if it weren't so cloudy. So remember to go out tonight between 5:30 and 6:30 and catch it for yourself. So the two planets are going to meet in the southwestern sky, and they look very much like a bright star. If you have a pair of binoculars, you'll be able to see them as two separate objects. So yeah, that's the end of my presentation today. It was a pleasure giving you this presentation. And now I think we have some time for questions.
We sure do. Can I just ask a quick question though, Jacqueline? So you talked about how the one photo you had showed how they were getting closer. So how long does it take for Jupiter and Saturn to drift apart? And I think that was actually a question that was asked as well.
Yeah. So if you've been watching them over the past couple of weeks, you've seen them get slowly closer together, a little bit closer each day, and they're going to drift farther apart at about the same rate. So if you go out tomorrow and it's not cloudy, you'll still be able to see a spectacular view of the conjunction, and they'll slowly get further and further apart each day.
So all is not lost for us here.
Exactly.
In Southern Ontario where it's cloudy.
Yeah, exactly.
So maybe tomorrow.
Yep. So
well, I see
if I can see the questions.
Yeah, there's lots of questions in the chat. Look at them all.
That is a lot of questions.
Oh, here, can I ask a question of you? So Sandra asked, when you think of Saturn's size, are the rings included? That's an interesting question.
So, that is a good question. So when I talk about size, I'm talking about their mass. So how much stuff is in the planet, how much it weighs. So Jupiter weighs the most out of all the planets. But including the rings, Jupiter is still bigger than Saturn. So I'm just gonna look at.
Oh, so someone asked, I guess someone's calling or watching from the West Coast. What time might this conjunction be visible in the West? So I'm assuming someone means the West Coast.
Oh, that is a good question. What time will the conjunction be visible in the West? So you just have to, I guess it would be 3 hours ahead. So whatever So if it's like 5:30, then I guess 2:30. So you might not be able to see it if you're on the West Coast that well. But keep an eye out at sunset. Maybe you'll still be able to see.
Oh, and then can I ask a question, because it sort of goes, someone had asked in the chat about the link to the observatory. So I put that in the chat function, so you can get onto that. But since Arizona is further south than where we are here in Hamilton, will it look different on the horizon?
If Arizona is further south, yeah, it should be higher up on the horizon. So you should have a better view. Mm-hmm.
Okay, so this is an interesting question from the GTA. Where in the GTA can you see the best? If there are houses around me, will I be able to see 10 to 20 degrees above the horizon?
That is a good question. And I've encountered this problem even in Hamilton, if you're trying to look low on the sky. So 20 degrees is high enough that you should be able to see over the buildings once it starts to set. So you want to look earlier in the day, so right around sunset. So maybe 5 p.m. You'll be able to see them. But if you're going out a bit later, when they're further down and closer to the horizon, then just go to like a big parking lot or something. I've seen them when I was in a parking lot, or if there's a field nearby, you should be able to see them.
Oh, and that same person commented on your Jupiter earrings.
Yes.
How they look. I didn't even notice those.
Yeah, I've actually had these for about 5 years, so I thought it was
nice.
apt to wear them today. Somebody asked, can I see the conjunction between 5:30 and 6:30 tomorrow too? Yep, it'll still be visible.
Okay, so here's a question. Do all 9 planets ever line up? How often does that happen?
Oh,
what would it look like?
That is a good question. I mean, I'm sure it's possible, but it's going to be very rare. Yeah, I'm not exactly sure when that would happen. I'll have to look that up, but it would be a very, very rare event.
Okay, so a mom is asking, or a caregiver is asking on behalf of Molly, age 7. So how bright will it be? Like, what will it look like? Will it look like just a big star? Probably with the naked eye will look different than if you have a set of binoculars, correct?
Exactly.
Or a telescope.
Yeah. So with the naked eye, it will look like a star. And you'll know that it's the planets because around sunset, you can't really see stars. So if you see a really bright object, actually anytime, if you see a bright object near sunset or sunrise, then you're likely looking at a planet. Most of the time you're looking at Venus actually is really bright around sunset or sunrise. It's in the direction of the sun. So that would be the only time you would be able to see Venus because it's closer to the sun than us. But yeah, it'll look like a bright star, basically. And if you have binoculars, you should be able to see them as 2 separate objects, actually, very close together. And if you had a telescope or a really, really good pair of binoculars, you might even be able to see Saturn's rings.
Really?
Pretty cool, yeah.
Oh, wow.
Mm-hmm.
Better dust off my binoculars then. Now on this, it's a little bit of a tangent, but it's an interesting question since you were just talking about Venus and then the 2 planets. Why do stars twinkle and planets don't?
That is a great question. So the main reason is because the reason things twinkle out in the sky is because of the atmosphere, actually. The atmosphere is distorting the light, and stars are a point of light. So you can see that distortion from the atmosphere a lot more than planets, which is because they're closer, it's an extended piece, an extended object that is putting out rays. So you can't see the wobble of those rays as well in the atmosphere. So that it's the rays wobbling in the atmosphere that makes stars twinkle.
Oh, that's interesting. Okay, so Robert, we have Robert in Calgary. He would like to know, where should they look? And is there a big difference? I'm guessing, is there a big difference to where Southern Ontario is to Calgary? Where would they look in Calgary?
There shouldn't be a big difference, but my friend here is actually from Calgary. Is there a big difference? If they're going to see it today from Calgary, it would be similar. 2-hour difference, but yeah, so you would be looking at 3:30.
In the same part of the horizon?
Yeah, the same part of the horizon. So yeah, if you look, and sunset is a bit earlier in Calgary too. So you should still be able to see it for sure. Go out at sunset if it's not too cloudy. Look towards the southwest.
Oh, here's an interesting question. Again, a little bit not completely on the topic, but interesting. David remembers once seeing the moons of Jupiter through some high power binoculars. Is this possible, or was he mistaken?
Yeah, it should be possible. I haven't, so I can't confirm 100%. I've seen them through a telescope. But yeah, I would think you would be able to see the moons of Jupiter through binoculars. It would be like little tiny points if you have a really, really good pair of binoculars.
And a good set of eyes.
Yeah.
Someone would like to know, how many millions of miles are Jupiter and Saturn from Earth?
Oh, that's a good question. I don't have that number off the top of my head. Also because I work in kilometers and light years.
Right. That's probably something we could Google though.
Yeah. I think we can Google that.
So Amber's asking, what color is it going to be? Will it be like Mars, sort of red, Venus, just kind of white?
It will be just kind of white. If it's really low in the sky, it might look a little bit red because of the sunset effect. Because basically, if there's more atmosphere between you and the light, then a lot of the blue rays are absorbed and you see more red light rays. But that would just be an effect of our atmosphere, not of the light actually coming off of the planets.
Oh, here's a good one. What is the difference between an eclipse and a conjunction?
Right, so that's a great question. So an eclipse is when it actually passes directly in front and completely obscures the object. And like I was saying before, a conjunction, it just has to happen along the same right ascension line. So they can go like this and not pass in front of each other. And this would be right here. That would be a conjunction still. So today one is not going to completely obscure the other. One will pass in front of the other though. And that's why we're saying that they're very close together. And that's what's so special.
Hopefully that was from Yankee. Hopefully that answers.
So I got the distance to Jupiter is 888 or 887 million kilometers. And you got to convert that to miles. I'm in Canada. That's
sorry, I'm just still looking. Lots of questions in here. Oh, well, here Andy has the $1 million question. I don't know if you can answer this one. Is there another planet with life on it?
Is there another planet with life on it that we can talk to? We haven't found it yet. So stay tuned. That would be cool. That would be very exciting once we find life on another planet. But earlier we did find microbes or something in, nope, never mind.
So Ed is asking what time of day, sorry, this is regarding to the Lowell, what time of day would be best to log into the Lowell Observatory link? For anyone who's interested, they said that they are going to be live streaming at 5 p.m. Mountain Time, which is 7 p.m. our time. So if you just click on that link that I put into the chat, I think it will take you to it. And if you don't see anything on it, because it's not 5 o'clock yet, Mountain Time, 7 o'clock our time, sorry, 7 o'clock Eastern, I shouldn't all assume that you're here in Hamilton, then yeah, I would occasionally look back go and click on that link, and then hopefully at 5 p.m. Mountain Time, 7 p.m. Eastern Time, they will start to broadcast. Also, in the email, the invitation email that went out to a number of people, the Alan Carswell Observatory, which is at York University, they are also going to be live streaming from 4 to 6. They're going to do a little presentation, although York University is not that much further from Hamilton where we are, so the sky's probably not going to be super clear to watch it from them. But yeah, it kind of is. But they have a big telescope. They have a 1 meter telescope, so you still might be able to see something. So that's, if you want to check out those, you know what, I will put that in the link in the chat right now for everyone. So if you want to check out the Carswell site. Sorry, everyone. Let me just. Yes, I'm looking at it right now. A winter holiday star is appearing this December 21st. They have a great conjunction live viewing, weather allowing, and an online show from 4 to 6. Now, when I was corresponding with the gentleman who runs the observatory, he said they are still going to have this show. Whether or not you'll be able to see the conjunction probably remains to be seen, but at least they are doing something. They're still doing some kind of show. And to be honest, that's why we put, I asked Jacqueline to speak at 3, so that if you wanted to log on to other websites, including this one, and I just put it in there with the York, you could do that. So today you'll be full of information on the Great Conjunction.
There's one more thing I would like to add actually before we go, and that is the software that I use to show you in the presentation, where you can find where objects are in the sky. This is free. I downloaded it for free. So you can download it and you can track the conjunction yourself and other conjunctions you might want to see or other things in the sky. It's called Stellarium. So if you just Google Stellarium software, then you should be able to download it.
Oh, great, thank you. Well, I think I see that most of the questions we've tried to answer most of them, and they've sort of come to an end. So I think with that, we will wrap up today's presentation. Thank you so much, Jacqueline, for imparting all of your wisdom on us. And hopefully everyone I saw in the Q&A, people were also commenting, thanks, it was a great talk. So thank you everyone for joining us. We hope you learned something and that you and your families can go out and enjoy something. And it's kind of nice, you know, we've had a very interesting year this year, and at least there's something special that nature is providing for us today that we can go out and enjoy, and maybe for a few minutes forget about all the strangeness that is happening in the world. Mm-hmm. So with that, we will thank you. Thank you, Jacqueline.
Thank you. And thanks everyone for coming out today.
We'll see you again. Have a great holiday. Take care.
Bye.
Bye.